All right, mathletes, here we are looking at our last unit this semester, adding and subtracting rational expressions. So let's build off what we kind of know from before, or should have seen in previous classes, is adding and subtracting rational numbers. So as you're adding and subtracting rational numbers, remember you have to get the least common multiple in order to add that, because that least common multiple gives you a common denominator. And so as I think about these and multiplying my fractions across, remember, you got to keep this value of 2/3. So you're really always just multiplying by some form of 1. So when you look at 8/12, you should rationalize and know that 8/12 is the same as 2/3, but it's written in a form that is more useful for us. In the same side over here, we're multiplying by 1. So we notice that we're going to get 9/12, which is the same value as 3/4. You can type them in your calculator and get the same decimal value. And then as you add these, you keep the top the same, and the bottom is 12. Okay, so as we're moving along and looking at these problems, here in Algebra 2, we're focused on expressions. So expressions are going to include variables. So as you're looking for your least common multiples, you want to think of them as your variables. And so here our least common multiple is 7b squared. So we have to get, what do we multiply to this term to get it to 7b squared? Well, that's a b, so we do it on top and bottom, so that value is 1. Same thing over here, a 7. Multiply across on the top. Now that you have a common denominator, you can do this operation, 3b plus 28, and that's how we're going to add and subtract rational expressions. Okay, so just as we said here, some core concepts is we got to make sure we have like denominators. So once we have like denominators, we just add the top and bottom. Okay, so we see two examples here. I'll walk through those other ones on the first side over there. A note with subtraction here. Okay, as we're subtracting, remember keeping the bottom the same, and that this can be the same as a plus a negative b. Many times I like to just simplify my problem by distributing that negative across, and then I don't have to worry about it for the rest of the problem. I just treat it like I would an addition problem. Okay, so if we want to find the sums here, notice I recognize we have a common denominator. So I can know my denominator is 12/x, and 8 minus 5 is 3. I can look to simplify. Looking at my constants, I have 3/12, which can simplify to 1/4. So I get 1/4x as my final term. Same thing over here. Recognize that I have a common denominator of x squared plus 1, so I can just deal with the numerator, okay? And I get x squared plus 1 over 2x squared plus 2. Factor out any common factors, see if things cancel out, and I get 2 x squared plus 1. Notice the same as the denominator, something divided by itself, its entire term. This value is 1, and 1 times 2 is 2. So 2 is our final answer. Okay, so as we noted on that first slide, we're going to be trying to find least common multiples, and you've done this a lot with integers, but now we're just going to do it with expressions that include variables. So the easiest way to do it is just to multiply by the other term. So you remember if you had like 1/3 plus 1/5 and you wanted to add them, the easiest thing to do was say, hey, look at this 5. I'm going to multiply by 5/5 here, and look at this 3. I'm going to multiply 3/3 over here, and evaluate it like that. That same thing's happening here. That least common multiple, this d, is being multiplied on both sides here, okay? And this c is being multiplied on both sides here, okay? And then you get your least common multiple as your common denominator, and then you just do the top across. Again, same thing with subtraction. I suggest trying to distribute that negative first. Okay, so as we're looking at least common multiples, so this would be like our common denominator if these two terms we're over some function on both of them, and we're asked to add or subtract them, and we want to find a common denominator. So the first thing you always do is factor, okay, to your lowest primes, okay, or at least your expressions to their least common primes. So with 4x squared minus 12, I recognize that there's a 4 that factors out. I'm left with an x squared minus 4. Okay, and on this side I get, well, they all have a 6 in common. I factor this out and I get x squared minus 4x plus 4. Okay, well, make sure, see quadratic, so now we need to factor that. So factoring this quadratic, got difference of squares, so the 4 stays out there and I get x minus 2, x plus 2. Keeps coming back. Okay, and then for the second term, okay, things that multiply to 4 and add to negative 4, feel free to use your diamond method to help organize your work. Okay, and we see we get 6, x minus 2, and x minus 2. So our least common multiple has to have every term present or present in its prime factorization. Okay, so if we look at 4 and 6, the least common multiple, I could multiply by 4 and multiply by 6 to 24, but really the least common multiple is 12 because 4 goes into 12 and 6 goes into 12. Okay, and then we have x minus 2 and x minus 2, so that has to be there. We don't need to write it twice for those two different ones. Well, this has an x plus 2, so I have to have an x plus 2 as my least common multiple because it has to be a multiple of that one. Well, there's another x minus 2. Well, that has to appear again. So we actually have this term appear twice. So 12 times the quantity x minus 2 squared times x plus 2 is our least common multiple for that. Okay. So finding the sum, again, the first thing I want to do is do my least common multiple, and that means getting my common denominator for these two terms. So I'm going to factorize them. So I can recognize, well, the first term's already kind of factorized. Okay. And the second term, I'm going to factor out a 3 and an x, and I get an x plus 1. Slip a hand here, this is a 9. There we go. Okay, so if I want to add these, I got to think about what I need to do to get that least common multiple. In my head, I know that it's going to be 9 x squared times x plus 1. Okay, if you don't see this, this is how we get there. Okay, so for this term over here, we got to make sure the least common multiple is this. So it doesn't have an x plus 1 term, so I need to give it an x plus 1 term. Well, by doing it to the denominator, I need to do it to the numerator to make sure I am only multiplying by some form of 1, and I'm not changing the value of our original expression. Okay, so now for the second term, I recognize that this 3 also needs a companion 3 to get it to 9. And this x also needs a companion x to get it to x squared. So as I simplify this out, well, 3x times 3x is 9x squared. I did it. It should work that way because that was the intelligent design we used there. And x plus 1 and x plus 1 is x plus 1 there. Distribute your numerator. 7 times x plus 1 is 7x plus 7. 3x times 3x is plus 3x squared. Now, just write them as, because the numerator and denominator should be written in a form of a polynomial. Typically, you write the higher orders first. 3x squared plus 7x plus 7 over 9x squared x plus 1. Okay, you'll recognize that this top is a prime quadratic, meaning that we can't factor it nicely, so we know it's not going to cancel out with the bottom. So we can just leave that as our final solution there for that sum. Okay. Now, for our last example here, looking at differences or subtraction. Okay. So again, I kind of want to first factorize my denominators. Okay, so I'm going to get a 2x plus minus 1 over x plus 2. So this is where I'm just going to change it to addition and multiply the numerator by -1, because subtracting something is the same thing as adding its opposite. So the opposite is 2x plus 1. And now I just treat this as a sum problem, and I don't have to treat it any different than I did on the previous example. I'll walk through this one anyways. Okay, go ahead and factorize this. So you get x minus 3 and x minus 1. Okay, so I recognize what is common with my denominators in order to get my least common multiple. So my least common multiple, my only integer, is the 2. There's an x minus 1 in both of them. I don't need it twice because they don't appear twice in either individual one. And then the x minus 3 is there. So how do I get this term there? Well, it needs an x minus 3. And what I do to the top, I have to do to the bottom because I'm really just dealing with a value of 1 here. Okay. Now, this term has both of those binomials, and it needs the 2. Okay. So as we distribute out our numerator, okay, I'm going to leave these. I'm going to multiply those out because I know I'm going to be adding like terms on this right side. So I should distribute these out. So x times x is x squared minus 3x plus 2x minus 6. Now 2, remember this is an entire quantity that we're doing. So 2 times this and 2 times this. So I get plus 4x plus 2. Now, as I simplify this out, I look for my like terms. I got 1x squared up top. Okay. I got a minus 3x plus 2x is a minus 1x plus 4x is a plus 3x. My constants, minus 6 plus 4 is a minus 4. That looks familiar, and it does factor, so I should break that down some more. And the denominator is already factorized because it's a common one. Remember, with adding or subtracting, we don't change it once we get that common denominator. And now, because this is not prime, I do have factorizations of -4 and 3 being -1 and 4. Okay, I can factor this to be x minus 1, x plus 4, okay, over 2 x minus 1 times x plus 3. Okay. Now that you recognize common things, these cancel out, and your final difference of these two rational expressions is x plus 4. You can put the parentheses around it, but now that it's by itself, it can just stay there. And then we have a 2 and just that x plus 3 left over. And that's our final answer there. That concludes our notes for this year. It's been a pleasure, guys. Look forward to seeing you guys back at Rocky. Bring any questions you have to office hours.